Hello and good morning. We are starting real programming today. So down to this point, it was all kindergarten stuff. We're just playing around. Today, we're going to actually start writing C++ code. So, and what I'm gonna do, I'm gonna start from scratch, starting a class. And every time that I'm teaching, I'm gonna make this class better and better as we go forward. Okay, so every concept that we are teaching, I'm gonna have this class that I'm gonna build today, and I'm gonna make it better as we go forward. I'll tell you why we need it. We create this class, we'll go through it, we understand the need for it. Based on the need, we're gonna go forward, and by the end of the semester, we're gonna have something that we can use actually. Now, let's quickly review what we have done last time. We talked about, we started the thing with a question about compound type memory allocation. I gave you an example of a book being dynamically allocated, and I showed you how it's no difference to do a dynamically allocated compound type or a regular type. They're all the same. A single entity always gets deleted with single deletion. So in here, if I am creating a function that actually creates a dynamic book and it returns a dynamic book, then it's the responsibility of whoever's owning that pointer to remove that from the memory to make sure everything is good. And we said that for now, set the unused pointers to null PTR anyway to make sure that you don't have any loose ends. So you can actually flag what you have as flag your pointer as something empty. We call that safe empty state. Then after that, we went through C strings and explained what C strings are. And we said C strings are simply null-terminated array of characters. There is no difference between an array of character and a string. A string is essentially applying a commonly used standard between programmers on a character array, which means I put the characters in an array, I mark the end with a null. That's a string. So there is no difference between a string and a character array. And remember, any functions that you use for strings are only applied for character arrays that are null terminated. Okay? The reason I'm telling you that sometimes you see people string copy an array of integers. I'm like, what? That's an array of integers, nothing to do with string. String is a character array that we follow a standard by marking the end with a null. That's all. Then I gave you an example of a person, how we initialize the person to an empty state, and how we display it, and all the good stuff that we have. And we showed that this has memory leak. Where is the D? Okay. Then we showed how we can initialize it with a value. So we create a function called init. And these are all standalone functions that we pass a structure to it. So essentially, we are going back to IPC 144. That's what we are doing. So we have functions. We pass the structure to the function for the function to change it. And we said, this is awful. We don't want to do that because each class based on one of the basic rules of object orientation, each class must have its behaviors and data encapsulated in itself. It should not have functions outside. That's one of the weaknesses that object-oriented people say about C++. They say in C++, you are free to write a non-object-oriented code, where in languages like Python or Java or C#, you can't. Okay? It is object-oriented. Like in Java, you cannot have a main. In Java, you cannot have a main function somewhere. You have to create a class. Inside that class, you have to create a main function. But we are not teaching Java. What I'm saying is that they say that's an object-oriented thing. In C++, main itself makes the the language, a language that allows you not to write object-oriented code. And this is a perfect example for it. I have display that is a function that receives a person. That's absolute disaster in object orientation. Again, it's like nobody is able to see you until you go to a box. As soon as you get into a box, everybody can see you. Then you come out. That's the display function. That's stupid. Every object should be able to display itself the way they want. And having the thing outside doesn't make sense. Then from there, we went to memory resizing. ABCDE, yeah. Memory resizing, and we explained that, like, for example, the person's name, if it wants to change, how we can actually resize the memory. And we said that to resize the memory, we need to have our memory. We need to keep track of the size. We need to allocate the new size that we want. We need to copy the old stuff to the new one. When we copied everything, we get rid of the old one. After getting rid of the old one, we make the pointer point. We update the size. We make the pointer point to the newly allocated memory. And after everything is done and the dust is settled, we end up our pointer pointing to a new piece of memory that is bigger. So that was resizing. And we demonstrated how we did that using add to name for a person, which essentially we created a temp, created the bigger memory size of the combination of two things, copied the first part, concatenated the second part, deleted the old thing, and updated the pointer. And therefore, resizing was done. Then we created a structure. We called that structure a number. The number structure is supposedly, but this is out of dynamic memory allocation. Now we are going back to encapsulation. So we created a structure called number and say number holds a number inside. Its job is to hold the number. And then we initialize the number, we add to the number, we display the number, and we use that in the main. But then we said, this is not right. This is not object-oriented. An object-oriented number has all the functions inside. And we said it actually, we can have it as a structure and we can enforce privacy to it, which means now the class number of mine, which is fully private unless I say otherwise, has a number inside and I can do stuff with that number. And nobody can touch that number nobody can touch that value other than the number. Therefore, my class is encapsulated and I have data and the behavior for data encapsulated in a number. Therefore, when I have two numbers, each number can carry its own value, and I can tell to which number to display yourself or do whatever you are doing. Each number applies its own methods to itself. We said C++ refers to all the variables inside a class. What is the difference between a class and a structure?
Is public and private.
Thank you. A structure is public by default. A class is private by default. So it encapsulates it. Okay? So what I'm saying over here is that, through encapsulation, we set the parts and made sure that everything is private, and only the methods that belong to the class can access the information inside the class. Then, after learning all this, we went back to a person, and we said we can do the exact same thing to a person. Therefore, having a person as class, a person, and then we had initialization and freeing of the memory of the person in it. And we said that we are forgetful. I will forget to initialize a person. I will forget to free the memory of a person. Therefore, I need to have these things automated, which means when a class is getting created, certain stuff has to get done to make the class ready and put the class in a safe empty state. Or, not safe empty state, initialize the class with proper stuff. What is the difference between initialization and setting?
Initialization is setting at the point of creation.
I'll give you 1% for the midterm for that. Okay, so remember all these things that I'm telling you, okay? These are important stuff that you, because usually people don't answer these questions that I mentioned, and it makes me, I get goosebumps when I hear somebody, it fluently tells exactly what's going on. Appreciate that. You made my day. All right, so it initializes. So we need, because we are forgetting that we are initializing, they created these procedures. These procedures are created to be called automatically at the moment of creation. And we can do anything we want in them. And because creation of things happen in different ways, I can just create something by default, which means it is in a safe empty state. It's empty, it's safe, you can do whatever you want to do with it. Or I can create something by putting some initial values in it. These type of creations can be different, and you can set them all up, asking the compiler to build the object for you at the moment of creation the way you want it. And we call those things?
Constructor.
No. The other one. No, what did you say?
I says constructor.
Constructor, that's perfectly correct. Yeah, constructor. So constructors are essentially procedures. The reason I'll call them procedures is to put an emphasis on the fact that they are not functions, which means you should not call them directly. Calling a constructor doesn't invoke it. Calling a function invokes it, which means you can call a function and it does something for you and an action happens. You say, I call the function, so I want this action to happen. If you call a constructor, it constructs. It doesn't call a function. It's two different things. For now, for our level of knowledge, it's forbidden for you to call a constructor. You need to let the constructor to be called when the object is created. Okay? And you are never in your career it's supposed to call a destructor. What is a destructor? What is a destructor? Do you remember? You can guess.
The opposite of
the opposite of constructor, which is?
When the object is no longer used, it will be
So what does it mean it no longer uses it?
When it's being destroyed.
When it's being destroyed, okay? But you are almost right. So let's pay attention to the ladies who are supposed to answer now. I said, what is a destructor? They said, when the object is getting destroyed, the destructor is called. But to say it correctly, what should we call that? Anybody knows? Anybody? Because the answer was correct, but it has to be that little thing that you have to add to it. Yeah.
Deleting the allocated memory?
Not necessarily. I can do anything I want in a destructor. No. It doesn't put it in a safe empty state. It completely wipes it out. There is no safe empty state. When you demolish a house, you don't clean up the kitchen. You're destroying the house, right? Nah, not necessarily memory. We can do anything we want in the destructor. Anything you want to be done. It's not when the object is being destroyed. It's right before the object is being destroyed. If the object is destroyed, then nothing is to be called. So we have to put the sentence has to be exact. It's computer science. You cannot say when the object is destroyed. When you say when the object is destroyed, if you destroy something, then you can't do anything in it. It's destroyed. You have to say right before the object is getting destroyed, the destructor is called. Is that clear for everyone? Okay. So, and I can do that. And what is the syntax of these procedures? The syntax is the name of the class. So you put the name of the class. Because they are not functions, they don't return anything. There is no return value. They are just things that are supposed to be done at the moment of creation. And if you don't put anything in it, it means how it's going to get defaulted. So this thing is actually called in two different ways. Either default constructor or no argument constructor. It's referred both at the same way. So either we call it default constructor or no argument constructor. Okay, default or no argument constructor. And the other one is the constructor that we actually want to set things with. Okay, so I could say, okay, I want to create a person, and I want the person to get created this way, so I need the name and the age. So if I ask you how many ways I can create a person, you have to tell me in two different ways. Either you can default it, or you can create it with a two-argument constructor. So I have two ways of creating this. So now this is two-argument. And let's say I do this. Now how many ways I can create the class? 3. It could be no argument, one argument, only the name. That person will be 18 years old by default. Or two argument. So how many ways to construct this? 3. That's a question in your quiz. I'll give you something like this, and I say, how many ways I can construct this object? You have to say 3, although it's 2 constructors. Are we clear on that? We're clear on that? All right. And then the destructor. Obviously, we do all the stuff we need to do in the constructor to construct the thing. So essentially make the, like the first one is actually putting it in a safe empty state. And the second one is setting it. Okay? And it's very good practice if the things you are doing in here are something that are done more than once. It's not done in more than once in here because I was showing a progress of things. I first wrote the int in it, and I then called the init in a person. If you are just doing it in here, you don't need to write a function. Just do it in the constructor. But if later on you'll see that this init can be called in different places, instead of copying the code, it's a good idea to have that method. What is a method? What is a method?
Pass.
What is a method?
Pass.
What is a method?
Pass.
What is a method? Rescue anyone? Function in a class, or we call it member function. So we said C++ calls it member function, but object-oriented terminology calls it a method. A method is a member function. So yeah, so you can actually set it as a private method, okay? And then call it. And we have that all the time in every single object that you're using. Anybody of, like when, as I mentioned, when you're driving a car, you push the gas pedal and the car goes fast, or throttle and the car goes fast. Anybody knows how? No. You just know when I push that thing, it goes. Nobody knows how. Nobody knows that's actually, if it's a nice car, it's going to hold the handle of the carburetor, and it's going to suck the air and powder the gasoline into the pistons. Nobody knows that. You just know that those are private methods of a car that you are not aware of. The public method is the throttle. When you push the brake, the car stops. Anybody knows how? Exactly in detail? No. You just know magically it stops because lots of private stuff are happening in the car. The public method for you is the brake pedal. All right? You good? All right. So that's constructors and destructors that give you an introduction for. And then, yeah, this is the exact same thing. So that's where we stood. Today, we are going to actually first create a problem and show you how the problem is fixed through object orientation. First, our design is going to suck. It's going to look very ugly. As we pass through time and we learn more, we're going to make it more beautiful until it actually shapes like a good, nice object to use. Are we good down to this point? So that was the last session. Questions? Yes. Tilde? Tilde is, oh, thank you. Tilde is, tilde. Okay, tilde, not th. Tilde. Okay, tilde, that's my Persian self coming back on for a second. Okay, so tilde. So When you are creating a constructor, you use the name of the class for the name of the constructor. When you are creating the destructor, you put the name of the class for the destructor. To flag this, that this is a destructor, not a constructor, you put a tilde in front of it. So tilde name of the class is the name of the destructor, or deconstructor. You know that destructor is not actually an English word. It's wrong, actually. It's wrong. There is no word called destructor, but now it is. We are in object-oriented. So I remember that English savvy students of mine, I will say, so it's deconstructor. It's not destructor. So my apologies. Anyways, but I think now it's in the word, like some dictionary somewhere, probably, because it's been used a lot. All right? Questions? Suggestions? Objections? Soon, I'm going to demo you on the workshops that you're submitting, and how many of you are copying from each other to show you that it's going online. Be careful when it comes to the project. Workshops, we give it to you, we say don't copy. We put emphasis on it, that if you copy your workshops and you don't do it yourself, you won't be able to do the tests and you will fail. So we kind of don't care if you are actually copying behind the scene, but I will send you, you're going to receive emails that said your workshop is a copy of another student. So you will get the email soon, okay? Be aware of it. And if you do that on the project, then that's plagiarism. Be careful, okay? Heads up. And you're going to see that your workshop is a copy of another person in another section. It's like that, okay? Because you all are submitting through Submitter, so it gets archived. We know we have all the submissions, and I wrote the program that compares all the codes, and it's finalized. I tested it the other day, and it worked perfectly, so it's coming online. Be careful, okay? Heads up. Yes? It's a DNA test. It's a DNA test. So essentially what happens is that I get the fingerprint of your application, then of your program, and I get the fingerprint of the other program, then I will do a test. If it's 0, it means identical. It means the distance between the two is, if it's 1, it means completely different. So we go, no, it's not 2 options. So we go down to 40, 50% to see how close it gets. So again, you are allowed to copy. There is no problem as long as you cite it. It is in there. So if you actually are stuck and you want to submit the thing and you solved everything and one piece is not working, you can get that piece from someone. But you have to cite, hey, I got this piece from this person. And you lose 5%. You get 95% instead of 100. There's no problem. There's no shame in that. That's what we do in computer science. Nobody writes a program just by themselves. No one. Okay? So if you are getting a piece of code to make your program work and you cite it, good for you. And good for the person who's helping you. But you must give credit to the person who helped you. And lose your credit exactly that much. Okay? And you cannot get half of your code from someone else, say, hoping to get 50%. It doesn't work that way. It's 1 or 2 functions or not the whole thing. Anyways, that's just a prof doing wishful thinking and talking to their students. So, shall we continue? Arrays in C language suck. They do. Why? Because you create an array of integers, it doesn't know what the size is. If you pass the size, it crashes. And you pass it to another function, you have to always pass the size with it. Every single thing you are doing with an array is problematic because you have to keep track of so many things. We are living in an object-oriented world now. Shouldn't an array know what the size is? Oh, I'm 30 elements long. I'm supposed to know. If somebody's putting more than 30 elements, I need to come up with some kind of a way to fix that problem without crashing the program. Either letting the person know what's going on, or simply resize myself and make myself bigger if I need to. If you are creating an array of 20 integers and you go 22, it should be able to resize itself and make it 22. Why it should get stuck on a thing, right? So first, we're not going to do that. First, we're going to start with a regular array, and we're just going to go with that and then continue, okay? So resizing stuff, we're going to do little by little. But we're going to first start. And because we don't know how to, at the end of the semester, we're going to find out how to create classes that can have many different types. For now, we're just going to focus on what kind of array? Choose a type. Integer, double, float. What type of array you want me to create? Choose one. Later on, we're going to make it general. Int, integer array. Okay. I would go with double because you can hold an integer in a double, but you cannot hold a double in an integer. So, but you said integer. Anybody's okay with integer? Integer array? All right. So, I want to create an integer array. If I want to create an integer array, who has the microphone? Okay. Modules, we did workshop 1. So I want to create a class called int array. What are the name of the files I need to use for my module? Go.
Array.h.
Pardon me?
Array.h.
Yes, so no, not array. Let's call it int array.h. So the first thing I need to create is a header file. Give the yeah, okay. Seriously, you have your headphone on?
Oh.
Oh, okay.
I'm not even listening.
Oh, sure. Oh, okay, sure. Oh, whatever. This day and age, we weren't allowed to chew a gum in class. Now people come in with headphones. Anyways, so I want to create a header file, and in here I'm going to call it int array. Classes start with capital letters, never lowercase. So int array.h. So that's what I'm creating, int array header file, okay, .h. Okay, and when it says pragma once, you'll know in 3, 4, 5 what that is. So we said that empty header file should have, go ahead, what should I write?
Define.
Okay, what should I write?
Huh?
What should I write? What is the first thing I need to write?
Define.
No.
If def. If
No. Give it to the next person. Next person. What do I need to?
If not defined.
Thank you. So I write if not defined. Now we are in Seneca, right?
Yep.
So we write Seneca. Oh, Seneca int array h. What is the next thing I write? Let him answer. Okay, define. So the next thing we are writing is define, and we copy that. We do not retype it, because if you make a spelling mistake, then you're in trouble. So what is the next thing I write over here for an empty header file? Do you remember? You want to pass it or you want to answer? Either pass or answer. Don't give it to the next person over there. That's okay. Then you're going to come to okay. What do I write?
With the curly braces.
Nope. Pass. Oh, actually, keep going.
Namespace.
Namespace. Thank you. Namespace what?
Seneca.
Seneca. Thank you. And if it was not Seneca, whatever it was, this namespace always matches the beginning of that one. That's our policy at Seneca College. If you go work for, I don't know, Google somewhere, they have their own policy. They're going to give you a book that is 1,000 pages, and they tell you this is our coding policy, and you have to follow that. Okay? So our policy says that. So that's an empty header file. Then I have to create a CPP file for it. So I'm going to go over here, add new item. That's a CPP file, int array.cpp. And in that one, I will say include int array. int array dot h. And then what? Pass it to the lady in front of you. My lady, it's your turn. Okay. So what do I write over here?
You just included the header file. You include.
Wait. No. Include is written already.
Yeah.
So let me split the window so for you to see what I have. This is my header file. Now I'm writing the CPP file. This is an empty. So this is supposed to be done with your eyes closed. So the parts that I'm doing now, I'm not even writing any code. I want to prepare my files, empty files, to start working. What is the next thing I do to make that a legit, good, empty file to start working in?
You include the.
No include.
You use the namespace.
Thank you.
ST.
Oh, use the namespace, you said.
Yes.
No.
Using
Pass. Oh. No. Gentlemen, over there.
Using namespace.
No.
Set. No.
Anybody? Yes, namespace Seneca. Remember, we code in namespace Seneca. What you see is an empty module to start working with. Question for your midterm. This is going to be in your midterm. I'll tell you, you're working in this company, and this is the class you are creating. Give me the empty files. That's what you're going to give me. Anything more or less is not acceptable.
But before that, we have to have a iOS 3.
No. Well, what if you don't want to do iOS? Why? Maybe you don't want to print anything. Don't think cliche. Come on. We are not always. Like sometimes you write something that has nothing to do with input and output. Another rule, important rule of coding that I'm going to teach as I'm going through. Give me 2 seconds. You only include and use when you need. Only. Never, ever do an include just in case. Ever. And you never use in a header file. You only use in a CPP file. You are not allowed to have using namespace schmiggly-dingy in header files. Ever. Okay? Yes, sir. Why didn't I use? Because I'm not using it, I'm creating it. I'm saying I'm building a car. You're saying, why you are not using it? I haven't built it yet. You know who's going to use that? Main. The program who's using my int array is going to use Seneca. You follow what I'm saying? I am building whatever is needed in Seneca. That's my factory. That's where I'm in. All my code is in there, in namespace Seneca. Anybody who wants to use my stuff must use namespace Seneca. Does that make sense?
Excuse me, is it necessary to have an underscore after the Seneca in array underscore h?
You're talking about line 1 and 2?
Yeah.
It's not necessary, it's our policy. It's our naming convention, they say. So I put names, I put in my define statements, I always separate everything with underline, and all my variables are starting with lowercase. All my classes are starting with uppercase, and it's camel notation. Camel notation, you know what's camel notation? Every word starts with capitalized. You see that? In here I have int, array, I capital, and A, that's camel notation. So that's my naming convention. Since I'm the boss, that's yours. You're supposed to do it that way. All right? You be okay with that?
I mean, in the workshop, I think there is another underscore after the h.
Yeah, I know if they did that, should do it. Doesn't matter. Okay. Okay. The reason, like we used to have underscores before, underscores after, but C++, its own defined statements has an underscore before and after, so we removed it. Not to get confused with what standard C++ does, okay? If you go find out where the header files are in your thing, for example, open standard input output. Look at the top of the standard input output header file. see what they write. You'll see what I mean. Okay, so that's that. Now that we have done this, I'm going to create the class for int array. So I'm going to say class int array public, whatever I want to do, and then we start. Who has the microphone? Malady. It's on. Okay, so when we create an integer array in C language, what are the things that are created? Do you remember? Like if I create an integer, an array of 3 integers, what are the things that get created? Do you remember that? No. I'm engineering. I'm talking about behind the scene. When you say int A5 for 5 integers, what happens in memory? Do you remember that? 5 integers will go into memory and? No, it doesn't store the value. What does it do?
A pointer will point the
Pointer points to the beginning of the array. Remember that?
Yeah.
Pointer points to the beginning of the array. And that's what we want because I am engineering an integer array. I'm going to do the same. So I'm going to say over here, integer, pointer, m data. So the data of this array will be pointed by that pointer. That's what I'm going to do. And I don't know what the size is because they didn't create it yet. Be okay with this? We good? Okay. So now that I have this, I need to create this array of mine. How do I create a constructor that creates this by default? What is the prototype for it? You know.
Can you ask again?
Okay, well, sure. How do we create a constructor? What do I write to create a constructor for class int array? What do I write? You know the answer, I know, but some people just don't answer for some reason.
Pass.
We just did it for the person.
Int array.
Thank you. Int array, the same name of the class, you bad people. The name of the class. I want to create a constructor. I'm going to write int array. And it's a default constructor. A default, how many arguments a default constructor has? Kill me now. A default constructor. Nothing, no argument. I said default constructor or no argument constructor. Nothing. So we'll leave it empty. Right? So if you, and I don't want to do it in line anymore, I'm going to create the body over here. So this is going to be int arrays constructor. And I write the code over there because it belongs to that. So that's how member functions and constructors are created outside of a class. You don't put a dot because you are defining them. You put scope resolution. Yes?
On the source file, is the first int array the name of the class and then the other one?
Yes, the first one you will see for the methods when we go through. The first one tells you who's the owner. The right one says what of the owner. Okay? You good? All right? So if I want to, yeah, something like that. Okay? So that's that. Are we okay with this? This class is going to be so ugly. You'll see that. Like when we use it, you're going to say, yuck, what the heck you're doing? But within 2-3 weeks, it's going to look beautiful. Okay? Which means when I say beautiful is that it's going to look and act exactly like an array. Exactly like an array. Like when you say integer A5, you can say A2 is equal to something. We're going to make that happen. But little by little. Okay? So number one, we're going to create int array. So that's what we're going to create. Now the int array that I'm creating, I want it to be in a safe empty state. What is a safe empty state? Recognizable empty state for an integer array. It's for this to point to nowhere. That's an empty array, an array that has nothing, no elements whatsoever. Are we okay with this? So all I need to do over here is to say mdata is set to null PTR. Are we okay with this? Anybody have any problem with this? So if you create, and I'm going to create the main right now. So in here, I'm going to actually include, and remember, always standard includes are at the top, custom includes at the bottom. So in here, I'm going to have include int array. Now in here, I can say int array A. Oh, why is it giving me an error? Why it doesn't recognize it? You can pass it to the gentleman behind you. You know why it's not recognizing it, although I have it in my header file? It's difficult to answer because you never faced it, but
because maybe it's not defined as class in the main.
it is defined because I included the header file. Thank you, the namespace. Thank you. Yes, so the namespace, using namespace Seneca. You have 1% for midterms there. Okay, so using namespace Seneca. Now it can recognize the int array. Now we know where we are using, when we are creating. Are we good with this? All right. So int array A, right? Now it's actually created. I can actually compile and run the program. Oh, I can't. Why? Syntax error before this and that. What did I do? Ah, I forgot the semicolon here. One more time. And I didn't close. Where did everything go? I think we're good now. And here's the execution. It did nothing. I created an empty array. It does nothing. Just, yeah, that's it. All right? Now, what is the next thing I want to do? I want to actually create an array with elements. So I want an array together. I want an array with 50 elements in it, with 10 elements in it. Okay? So that's what we're going to do. So can you help me with the signature of it? What is the name of the constructor?
Int array.
Thank you very much. Pass it to the gentleman. Actually, recycle. My lady, it's yours. Okay. So in this constructor, I want to tell to the class that I want this many elements. What should I pass as an argument? What do you think is a good thing? I want to say how many elements? So I want to be able to do this. Let me put it over here. I want to be able to do this. I want to be able to say int array, that was the default one, int array B, and I want to be able to say over here, I want 10 elements in here.
In size?
Int size, fantastic. Int size, int size. That's beautiful. So I need to pass the size, how many things I have, right? Right? Are we okay with this? But remember what I told you, that we have something that is good for size because it never goes negative? What was it, that type? Anybody remember? Size T. So instead of integer, it's better to use size T because it's never going to go negative, right? So size T is what we are going to use, and it works fine. But because I have the size, and we know that classes, arrays in C suck because they don't know what the size is, I have the tools. I'm going to make it sure. I'm going to make sure it remembers what the size is. Therefore, in here, I'm going to say size T, M size. And now that I have that one, I have to make sure that in the default constructor, I'm going to make M size 0.2. It means it has no size. It's completely empty. Okay? Now let's implement that. Let's implement this constructor to actually get the size and build the array for us. So what do? You see the screwdriver over here? If you are using Visual Studio and you're too lazy, you can just click over here and say, create definition in int array.cp, and poof, it creates it for you over there. So you don't have to type it, okay? But I strongly suggest initially start typing it so you get used to it, because you don't have that luxury when you're using Notepad++ in a test, okay? So remember, first you write the name of the owner. What is the name of the owner class? Scope resolution, what are you building, and that size. Okay, so what do I do in here? I'm going to say, so I need to have size integers. And we just learned in dynamic memory allocation how to do that. So I'm going to say mdata is equal to new int size. Ta-da! I created my array. And I'm going to remove this stupidity from integer or from C arrays by saying, hey, m size is size. Now it remembers what the size is. Finished. Okay? So I created the array. Did I need to set mdata to null before this? No, because we understand constructors happen at the moment of creation. Because it's at the moment of creation, it's a brand new object. I don't care if it's null or not, because I'm setting all those things. If it was halfway through, if I was resizing the array, then I need to be worried about it. But if you are not doing, you're not halfway through the lifetime, you are in constructor, and that's the case. So now that I have the size, it's a good idea to make the integer array tell to whoever's using it what the size is. So I would like to be able to say cout b array has b dot. What should I call the name of the method that tells what is the size? Remember that we can call the methods using a dot beside the name of the class? So I want to write the name of the function that tells me what is the size of the array. What should I call that?
Array size.
Okay, array size is good. Okay, so he says, let's call it array size. Okay? Wait. If I want to tell you how old you are, what is your name? Narabi? Okay. What do? I say Narabi dot human age, or I say Narabi dot age. So B is already an array. Why you are bringing, that's C behavior. In C behavior, we want to bring the name of all the stuff into the array, into the name of the function, because we don't know what the function is doing. But when function, it belongs to an int array, why do I need to have the name of the array here? Size is enough. Do I make sense? So in here, I'm going to call it size. And capitalizing it was wrong because methods start. So I'm going to say size, and in here I'm going to say elements. Okay? Now I have to fix it. This is how I program. I call what I like it to be, then I fix my code. Make it happen. So, whose turn is it? Your turn. Okay. What should this size return?
It should return an integer. Oh. Sorry.
What is it supposed to return?
It's supposed to return the size of the...
Size of, and what is the type of the size?
It's a size t.
Size t, so beautiful. So it returns size t, okay? And the name is size, and that's it, right? And then in here, I'm going to say int array scope resolution size that returns a size t has this definition. What does it do? It returns the size. You understand this? These type of methods, what is a method?
A member function.
A member function, okay? These type of methods that give information to you about the class they belong to are called queries. Remember that. Query is a method that gives you information about the class. It doesn't change the state of the class. If I ask, how old are you? And he says 19, he's not going to turn 22 because he answered that question. He's going to remain 19 years old. I hope I didn't do just injustice to your age, but whatever. Okay? Do we understand this? So a query is not supposed to change the owner, correct? If you wanted to receive an argument, a pointer and pass it to a function, and you didn't want that pointer to change the target, what did you make the pointer? If you want to make a pointer read only, what do you make it? You make it a to make something read only in C, what do we add to the type?
Constant.
Thank you. Constant. So in object orientation, you can make a method incapable of changing its owner by adding a const here. Would it have worked if it didn't have the const over there? Yes. Do we have to add the const over there? Yes. Because we want to make sure we're not going to shoot ourselves in the foot by mistake. If size is supposed to give you information about the array, it's not supposed to change the array. Therefore, you should enforce that. So by mistake, if you did something stupid in here and you said m size is equal to 10, it's going to tell you, hey, what the heck you're doing? This expression must be a modifiable L value, left value. It is not. It's not modifiable. Why? If I remove that, it becomes modifiable. If I have that one over there, then it cannot change the owner. So if your method is a query, 99.9, you have a const over here, remember. What is a query?
Get the values. Get the.
Yeah, give me full sentence. I know it gets the value. What is a query? Get values. So what is the what gets the values?
Get the values of the class attribute.
I forgot what was my question. What was my question? What is a query?
Get the size.
No. Query is a method that gives you the values and information. Thank you, pass it up. Okay. So method, query is a method, is a member function. Okay? Are we good with that? Are we okay with that? Fantastic. So that's that. When does the class end? 12:30. 5 minutes break. Go breathe, because I see you guys are going, woo. Okay, 5 minutes break. We'll come back. So I had a very good question during the break asking, can you give me the timeline of what happens and when it happens? And I said, wait for it. Let me write 3 more things so I have something to walk through, and then I'll explain it. Are we okay with that? Okay. So very first thing after creating a constructor that I didn't do over here is to creating a destructor. Why? Because every time I'm running this, I'm causing memory leak. Because it keeps allocating memory and it doesn't delete it. So I have to write a destructor for this to make sure every time I'm testing it, it's not going to screw things up. So what do? Destructor was simply a tilde and then the name of the class. So I'm going to write int array and that's it. Okay? And to implement it, you do the exact same thing. So you write over here int array tilde int array. That's the destructor. What do you do in the destructor? You delete the memory. So you simply say delete mdata. Do I need to check to see if it's null before I delete it? The answer is no if you review the dynamic memory allocation. Because we said delete mechanism has the logic inside that if something is null, it's not going to touch it. Okay? It only deletes if there is something in it. And because I am following the rule of setting null values, okay, setting stuff to null, okay? So now that I have this, I need to be able to get the element of the array and set the element of the array. So I'm going to write two methods. I told you it's going to be ugly initially, but it's going to get better and better as we are going through. So to set the element, I want to set the element of the array. Who has the microphone? Okay. So if I want to set the element of the array, what should I call the name of the method?
Set element.
Set element. Okay. So I'm going to write set element, and because I'm lazy, I'm going to just set lm. Okay. So that's set element. Okay. What do I pass to it?
An integer.
An integer. That's the value that I'm passing. What do I return?
Void.
Void. Are we all good with this? Ladies and gentlemen, representing set element. Does set element need to be constant? No, because it's changing the object. I am setting the element of the array, right? So that's good. Now, next one. Now, the other one, I want to get the element value. What should I call it?
Get element.
Thank you. Element. What should it receive through argument list? Nothing. I don't need to get anything. Do I need to put anything in here?
No.
Wrong. I misled you. No, I need to. And even the set element is wrong. But anyways, so we said nothing. What do I return in get element? Integer. So I pass it. Okay? So it returns an integer. This one receives a value. But I have a question. How many elements an array has? I don't know. It has size 10. Which one I'm supposed to put it in? I have to tell which element, right? So I need to have an index in here. So set element needs an index. So size t index. And then the element. I told you it's going to be ugly, but we're going to make it beautiful. Get element needs to know which index I am getting the element for. And this one, should it be constant or no? What do you think? I am getting information from the array.
Yes.
Yes, it needs to be constant. Why? Because I'm just getting an element. I'm not changing the array. This is a query. This is a query. So let's actually write it in here. I'm going to call it over here queries. And we call this modifiers or getters and setters. These are queries. These are modifiers. OK? All right. So let's do get element. What does get? So set element. First, let's do set element. Set element. So if I want to set element, what do I need to do? I have the dynamic array over here, mdata, right? All I need to do over here is to say mdata index is set to value, right? That sets the element of the array, correct? But remember, we want to make this class intelligent. We don't want it to be dumb. A dumb array is you put an index over there, the index is bad, it's going to cause trouble. We don't want that. We want to make sure that it only does that if everything's okay. The first thing that we need to know is my array valid? Does it have an element? How do I find out if it's in a safe empty state or not? So the very first thing I need to do is to check if mdata is not equal to null PTR. That's the first thing I need to do. I need to do this. If it's not null PTR, come in here. What is the second thing I need to check? I have 10 elements. What do I need to check?
Size.
Size. I need to see if index fit within the size. I need to see if index actually is a valid index. 10 fingers. What are the valid indexes? 0, 1, 2, 3, 4, 4, 5, 6, 7, 8, 9. So whatever the size is, index can go one below, right? Not more than that. So if that is true and index is below m size, okay? Smaller than m size, then I can do this. You will see that when you follow the logic, the first one is not needed. Because if m size is 0, you can't put anything. Okay? So forget what I said. This is good. Because it's completely ignore what I said. I was absolutely wrong. Okay? Forget about it. But anyways, so this one guarantees that it's not empty. And this one says, if it's less than size, you're good to go. Okay? And it sets the thing. So that's safe. Okay? The next one is get element. So when I'm getting element, what do I didn't put index in here? Index. So in here, I need to do the same. So I need to say essentially the same thing over here. Right? But the problem over here is that, what do? I have to return. So if everything is good, I have to return the value of the element, right? So I have to say return mdata index, right? Otherwise, I should return some garbage value, right? So if they exceed the size, index goes beyond size, it's going to return just 0. And I'm giving them the tool. They can check what is the size is. If they are careless, they don't check the size, and they do that, let them get garbage. This is a bad code, not allowed in my class. 2 return statements in a function you are not allowed to do. Your functions are allowed to have 1 point of entry, which is coming in, and 1 point of exit. So if you have something like this, always create a temporary value for it, which is integer return, and you set it to empty. Now in here, you're going to say return is set to mdata, and you say return whatever you are returning. So if it's valid, ret will be overwritten by whatever value you have in its return. If it's not, it's going to return 0. Are we okay with this? Now let's walk through. Okay? So in my, I told you it's an ugly, ugly array. But we're going to make it better as we go. So that's the size. Now I'm going to say over here, for integer I set to 0, I less than, let's go size t. Size t I set to 0, I less than, I don't know, 20 and I++. I'm going to say B dot set element to I multiply by 10. Okay, I'm just putting some value in. Are we okay with that? Right? And then in here, let me just bring the size t out. So it's setting the element. Why is it giving me an error? Too few arguments. I forgot the index. Okay, I and, my apologies. So put it in the index I, put the value I plus whatever. Are we okay with this? Now, for the other one, I'm going to say C out, get element I. Okay, I'm just going to run it first, and then we'll see what happens, okay? You see what happened? The size is 10. I put 20 in it. Because I put 20, it ignores the rest of the stuff. And the rest will be zeros. And it didn't fail. Nothing crashed. Everything's beautiful. Okay, so it's perfectly safe. If the user was not like this, like if the user was a good user instead of 20, so let me put this one over here. I'm going to say bad main, A. If the user was sane, they would actually write over here b.size. And here would write b.size too. And now if they print it, sorry, I changed the wrong file. Copy. There you go. So now if you run it, it actually knows what is the size. It goes exactly up to that. It's not going to go more than garbage. And the good thing about it is that if I actually have something like void display const int array reference I can simply have this logic right in there. And all I have to do is to say display I. Oh, not I, B. I don't need to pass a size because B knows what is its size. Unlike the arrays that we have in C, so if I actually run this, it actually shows the elements of the array perfectly. Are we okay with this? Are we okay? This is where Git comes into play. So what I'm going to do over here, I'm going to say, I'm going to come to the commit thingy. I'm going to say commit, select all. I'm going to say int array before references. Commit and push. Oh, I have to pull first, sorry. Oh, what happened? What was the error? One more time. Get a permission, unable to index. Oh, yes, close. That's the reason, sorry. I have something open over here. did not match any, abort, sorry, cancel. Yes, cancel, I'm gonna commit again. Sorry, I had an application open. I'm gonna say int array before reference. So when you are looking at the code, and you'll see what the differences are when I'm going to make the change, okay? You'll see what changed. So in here, I'm going to say, and for your sake, I'm going to do something like this. So I'm going to save that as int array. So that was A that we added, right? I added, what do I have in here? Just a second, let me see. It's A. Now I'm going to have B and C. So in here, I'm going to have B. Save. And I'm going to have this one. Now, I want everybody's attention on this. This is an important part of the thing, of our usage of the knowledge that we have. What is a reference?
Address.
No. What is a reference? When I create a reference to a variable, what do I do?
It's making an alias.
Alias. So it's an alias. So a reference is essentially an alias. Are we okay with this? A reference is an alias, which means, remember about crazy reference? It means none of you studied. I created something, I called it crazy reference. Crazy reference was the function that was returning a reference. And we said you can actually set the function to something. Remember that? Okay. So that's why you study before you come to class. I'm going to create the crazy reference over here. What is a crazy reference? I'm going to remove these two things, modifier, query, shmwery thingies. I'm going to create something like this. Int element and size t index. But instead of returning an integer, I'm going to return an integer reference. So what element is returning is an alias for an integer, whatever that may be. So in my code, in here, I'm going to remove this, and I'm going to remove this. Oh, I'm going to need that. Then I'm going to remove it. I'm going to do this, but there is a problem over here. Here is when it's allowed to have two return statements. Remember I told you you need to understand how the rules are and break it when needed. This is the time. So in here, I am returning, just to show you first what it is, I'm going to remove all the if statements and everything. And I'm just going to say, return mdata. Nothing else. What's happening here? I'm saying when somebody's giving me an index, return the element, an alias for the element matching that index. You follow down to this point? Okay. Now let's go back to main. This main, so that's C. So in here I have to say Alt F-A. I swear I had a B saved somewhere with .h. Oh, because this is CPP. Okay. So if it's a BC, this is D. D, and I'm going to call it no ref array main.cpp. See what I'm about to do. Let's first remove this because we don't have all these things now, and then we're going to fix it. See what I'm going to do over here? I'm going to say b dot element 5. What does this return? Wait. What does b dot element return? Reference of an integer. Which one? An element of the array. Because it's a reference, the function itself becomes a new name for that element. Therefore, I can put it at left side of an assignment. So I can put over here 500. Now, I can actually say cout b dot element 5 and down. And if you run it, you'll see it's actually there. So the set get element and get element are gone because now I can return the reference of the element itself. So it's getting closer to what I wanted to do. I don't have to have a set element and a get element. So how do I fix the problem with index? That's where I love math. I don't even need to write an if statement here. OK. Anybody knows what modulus do? IPC 144? The percent thingy? Remainder, right? It returns remainder of something, correct? Now, what happens if I do this? Let's walk through. Let's walk through, OK? Let's say size t is 3. Let's say m size is 3. Let's say m size is 3, OK? If index is 1, what is the outcome of this? 1 divided by 3, what is the remainder? 1, right? Let's say index is 2. 2 mod 3 is 2. Let's say index is 3. 3 mod 3 is? Went back to 0. Let's say it's 4. Mod 3 is 1. Went back to 1. No matter what you put for index, the remainder is always 1 less than m size. So if they ignore the size of the array, they're going to shoot themselves in the foot, no one else's. It's not going to crash or anything. It's just going to come back and it's in their own memory. You follow? So now, if I do this, I don't even need to write an if statement. See that? All I need to do now, I can actually write the for loop. I can write for size I set to 0, I less than, I don't know, I'll put 12 and I plus plus. And I'm going to say b dot element element of I will be set to I plus 1 multiplied by 10. OK? And then I'm going to write the for loop again and print it out. So remember, it's 10. I'm going 12. If I run this, you will see that it becomes 21, 22. You see that? So 13, 14, 15, it starts from 10, 10, 11, 12, sorry, 11, 12, 13, it goes up there. I wanted to do multiplication. I think I did plus by mistake. Yes, this is multiply by 10. Let's do it one more time. Sorry. There we go. So it goes 10, 20, 30, 40, 50. It goes 100, and then it comes back and then rewrites the thing over. You see that? So if they keep going, it's going to just ruin their own data. Nothing's going to go wrong. They can keep going as much as they want, and it's not going to ruin the data. It's not going to destroy anybody's data. It's just going to come back. Okay? Now, final thing is that if I actually write over here a display, then what's going to go wrong? If I write over here void display, same thing that I did before, constant int array, reference I, because I know when I want to print something, I don't want it to change, right? If I actually use the exact same method over here to show it, same logic, I'll be in trouble. Why am I going to be in trouble when I want to use display? And let's actually go back with size. So in here, I'm going to say, let me just, give me a second. Give me a second. X, save this. Give me a second, please. Let me save this. Where's my sig? There we go. Okay? So now, if I bring back this up, and I try to do the display instead of doing it in here, you will see that this is actually getting an error. What is it saying? Object has qualifiers that are not compatible with the member function Seneca int array element. Object type is constant. So your object is constant. You are calling a modifier. It won't allow you. So what do we need to do? We need to make sure that we have the exact same thing that is not capable of changing this object, which means I have to copy the exact same thing and put the safeguards around it. I have to bring it over here, say, okay, I'm going to return a constant reference, and I'm going to make sure it's not going to change the object. And add that one to my methods. So what's the difference between the two? This is a modifier. This is a query. Remember, functions can be overloaded in C++. They have the same name, but they have different types. One is constant, the other one is not. Therefore, the proper one will be called. Now, if I come back over here, you will see that I have no problem. Now, if I run this, it runs perfectly, and then after that, we're going to go to the timeline one by one and see what happens. Okay? And also, I'm not gonna print up to 12. That's just bad. IDA size. I'm going to make that IDA. So the whole purpose of this thing is that to go up to size, right? So b.size. First run it, make sure it works properly. So we are going from 10 to 100. Everything's good. Okay, so now let's walk through. Okay, and also, by the way, let's display B2. Display A2, and you'll see it's going to crash. I'm going to fix it afterwards. If I display A, what's going to happen? What is it? Stupid compiler. Okay. Okay, so if I run it, you'll see it's going to crash. It's going to crash. It's supposed to crash. Anyways, it will. We are lucky it didn't crash, but it should crash. I'll explain later. Okay. Actually, it didn't crash because I checked the size. That's why. If I didn't check the size, if I just printed an element, if I do this, that's going to go back. It crashed. See that? I'll explain later. Now, that brings us to the multiple return statement. So this has still flaw, but let's first walk through timeline. The program starts. And let's bring everything into one screen. The program starts. By the way, how do I do walkthrough? I am pressing F10 to jump over and F11 to walk through. So I'm coming to here. I'm pressing F10. That executes it. You see that? Now I'm pressing F11. It goes to the default constructor because I had no arguments in here in main. There was no argument. It goes to no argument constructor, sets mdata to null, sets the size to 0, and comes out. Safe empty state. Then it comes to int array. Now it's one argument, goes into the argument, receives the size of 10, allocates 10 integers, puts the address in mdata. Now mdata is pointing to 10 integers. And it keeps track of what is the size, so size is 10 too. Now, we are setting the index to I. B has, oops, I should have, so I want to go back over there. You can backtrack by this, going back. I'm not going to do that. I'm going to just stop. Now I'm going to say, come around, run down to here. So I'm going to put a stop sign over here. Now I'm pressing F5. It comes right to that point and stops. So everything is done down to that point. Now I'm going to press F11. As you see, it goes to the size, returns the size of the array that is 10. Therefore, it's going to print B array has 10 elements. Then it sets the index number 5 to 500. So it comes over here, returns index 5, the modular size that is 5. So the reference of mdata 5 is returned. Therefore, this becomes an alias for mdata 5. Therefore, mdata 5 will be set to 500. Now it comes back and does the same thing again. Again, returns the reference of mdata 5 because we just set it to 500. 500 is printed. Then it starts from 0, goes up to 10, one by one sets the elements corresponding to the index. It starts from 0, so mdata 0 is 10, 1 is 20, and it keeps going like that 10 times until all the elements are set. I passed it. Again, I stop. Remove that stop sign and come to the other one. Press F5. It goes and stop at display. Now I can go into display. I'll go to display. B is now represented by I. If I look at the content of I, I'll see that its size is 10. Therefore, the array is carrying the size by itself. And it's going to go through it one by one, printing the elements, which is all the 10 numbers. Goes to new line, comes out, goes to display A. It comes in here. Because I is in a safe empty state, size is 0. Because it's 0, nothing's going to get printed and comes out. So for that case, it works. But for the other one, it does not. If I actually set it, so if I actually, in here, set something like this, it's going to crash, and I'm going to show you why. Are we OK down to this point, by the way? You're OK down to this point, hopefully? Quickly, how do we study? You go home, you look at my code, walk through it, and try to understand what it does. You set it aside, you code it yourself from scratch, everything. Create the header files, everything, OK? After you do that, you test it, see if it works. And then you go back and forth without putting the codes beside each other until you successfully do this. That's when you learn. OK? All right. So the time is almost, is it 12:30 the next class begins, or 12:30 we finish? I always ask this question. 12:30 class finishes. Let me see. Yes, the other one starts at 12:35. We're good. So I can actually tell you the other one. So now, in here, I'm going to say, I'm going to commit, and I'm going to say over here, pre-multiple returns. I want to make this thing, this modifier, safe, which means I want to make sure, actually not this one. This one is always safe. The one that actually receives information. This one, I want to make it safe, which means if, and that one too, if mdata is null and somebody tries to set something, it's going to crash. It's not going to work, right? Imagine if mdata is wrong and they're trying to set something. If they try to set in here, say, a.element 10, if they do something like this, you're essentially trying to write in a null pointer thingy. And it's going to crash. As you see, it didn't work. It actually crashed. This is the reason. So it comes in here. It sets everything. We know that. It sets everything. We know that A is empty. When it comes over here, mdata is null. I'm saying put it in a null address. As soon as I do that, it's going to say unhandled exception. What the heck you're doing? Integer division by 0. You're trying to do it. Crazy stuff are happening in here. Let's not do this. So how can we actually fix these two values? OK? The problem that we have is that we don't have an actual integer over here to create a temporary value for. In the other one, I created a temporary value and returned the value of that one, remember? When it was out of bound. In here, I have to return an alias. I cannot return an alias of a local variable that is dying. When it's gone, the variable will be dead. I cannot return that. So what can I do? What you can do, you can go in integer here and create int garbage. So create a garbage variable over there and say, when they do something nuts, I'm going to return the garbage out. So now here's the place that multiple return statements is OK. So now I'm going to say over here, if mdata is not equal to null ptr at, oh, I don't need to check the other one. The other one is fine. OK. One return, else return garbage. So if they have data, they send the real thing out. If they don't have it, the element becomes a new name for garbage. They can put something in garbage, pick up garbage. It's their fault. They should have checked the size. You follow? This case says to return statement is fine. Remember, know the rule, break it when it's proper. Okay? So I can do the exact same thing over here for this one. And now this makes everything safe. If they try to set something in here that is wrong, then it's going to be wrong, and it's going to be some garbage. And they're going to overwrite the garbage. Let them do that. They didn't check the size. It's their fault. I gave the programmer the tool to check the size before they do something. If they didn't do it, problem is theirs. Are we okay? Go home and do this. All right? So commit. Int array. And we're going to keep doing this every single time you're coming in. Thank you. We're going to write another example, yet another example. If you can think of an example of anything that you want me to implement, you're free to do so. Come later and tell me, Fardad, create a class for this, and I'll do my best to do it if it's feasible. Okay? Thank you. Have a beautiful one.